This section is all about equations, so we kind of start with the basic ones and work from there. So x plus 7 equals 12. So on the easier ones, I only usually do one example, but if you need me to do another one, I will be happy to. So when you have this variable or equation like this, you're trying to get x by itself. So you want to move away everything that isn't x. Anytime you go across the equal sign, you do the opposite sign. So this is x plus 7. So I want to subtract 7 from both sides. That cancels these out, and I get 12 minus 7 is 5. And you can always take, you can always check it. Oh, I'll say can't always. You don't need to always. Okay, you can always check your answer by plugging it back in. So like if x equals 5, I could do 5 for my x plus 7 equals 12. And that does 12 equals 12. So it's like not a bad idea to do it on tests. I wouldn't do it every single time, but you can always check your answer by plugging it back in. Okay. If I have x, x plus, this is negative 4 equals 9. This is, you can rewrite this as like x minus 4 equals 9. Like that plus and minus becomes a minus. What you're actually doing here is you got to do the opposite sign. So I'm going to add 4 to both sides. Those cancel out, and I get x equals 13. I actually do want to do this one. This one, z plus 6 equals negative 2. Here, when I subtract 6 from both sides, you are doing negative 2 minus 6. I always think about money. If I owe you $2 and borrow $6 more, now I owe you 8. So it's negative 8. So be careful with your signs there. We can go over the rules for those integers if we need to in a bit. That's fine. Fraction. I'm going to write this like this, because I think this is more of what you'll see on Alex. All right. So there's a way that I do fractions that'll help us towards the end too. We don't like fractions. So what I want to do is just get rid of it. So you can just add 1/3 to both sides of this, and it actually works out nice and neat. But I kind of want you to go with this mindset because I just think it really is helpful, and it's the way to do it. It might be an extra step, but it makes it so much easier. So what I'm going to do here is I'm going to multiply everything in here by the LCD. The least common denominator is the smallest number that those all divide into. They're both 3 on this one, so it should be easy. So if I multiply everything in here by 3, and again, this may be an extra step, but I think it makes it so much easier and it will help you in the long run. 3 times x becomes 3x. This is a 3 and a 3 on top, so they cancel out, or 3 on top and a 3 on bottom, so they cancel out, and I just get negative 1. Oh, this is going to make this problem a lot longer. That's fine. 3 on top and 3 on bottom, and I get 2. Okay. So this actually ends up being a couple extra steps, but now, I mean, most of y'all can probably solve this equation, right? And I have an equation without fractions. Okay. So I'm kind of skipping ahead here a little bit, but that's fine. So to get x by itself, the first thing I want to do is add 1. And then to get x completely by itself, I divide by 3. Okay. Technically, that's a long way to do it, but this is just my brain, the way it works, because I try to do like try to make one way work for as many things as possible. So if you ever just see fractions, you can just multiply by the denominator or the LCD and get rid of all of them. And then you don't have to add fractions or subtract fractions or anything like that. So on this one, again, you can subtract 3/4 from both sides, but then you got to do negative 1/2 minus 3/4, which most people don't like that. So my LCD of 2 and 4 would be 4. 4 is the smallest number that they both divide evenly into. So if I multiply everything in here by 4, I get 4y plus 4 on top and the 4 on the bottom cancel out. Now here's a little bit different because the 4 and the 2 don't cancel out on this one, right? Because they're different. But 4 divided by 2 is 2, right? 4 divided by 2 is 2, so 2 times negative 1 would be negative 2. And now I have a problem without fractions. Again, this makes you do like 2 more steps, but I don't have to add and subtract fractions if I do this. So if you multiply by the LCD, it will get rid of them. So to get y completely by itself, I'm going to subtract 3 from both sides. And then divide both sides by 4. So y is equal to negative 5/4. Like I said, it actually makes you do 2 more steps, but if you do it the other way, I'll do it the other way just to show you. It's not going to hurt to do a adding and subtracting fraction problem. So here I'd subtract 3/4. So what I have to do is negative 1/2 minus 3/4. So to get a common denominator, my common denominator of these is going to be 4. This one's already 4, so I just have to rewrite it. But then you say 2 times what number is 4? And that's 2. So 2 times 2 is 4. So I multiply the top and the bottom by 2. So that becomes negative 2. And my answer would be negative 5/4. When you add fractions, you just add the numerator. You leave the denominator the same. So like most people don't like adding and subtracting fractions. So this, like multiplying by the LCD, does create an extra step, but it does make it so much easier. And once you get past this first section, we're always going to do that, and it only creates like 1 extra step. All right, so we already kind of did this because I jumped ahead, but when you have 3 times x, to get rid of the 3, you divide by 3, so you get x equals 5. So these cancel out, and that gives x by itself. This one, this is the easiest way to do this is what we were doing earlier. This is 1/2 times x. So what you want to do is just multiply everything by the denominator there. So if I multiply everything by 2, 2 times 1/2, again, a 2 on top. Like if you want to write it over 1, that's fine. But 2 on top and 2 on the bottom, you end up with just x. And 4 times 2 is 8. So on this one, again, my thought process is get rid of the fraction. I see 2/3, so if I just multiply everything in here by 3, 3 on top and a 3 on the bottom cancel out. So I'm left with 2y equals 24. And then divide both sides by 2. And y equals 12. Some people will teach you to do it this way, which is fine if you can handle this. But they say to multiply by the reciprocal. So the 3's on top and the bottom and the 2's on top and the bottom, they cancel out. So I do 8 times 3 is 24, and 1 times 2 is 2. So I get 12. You can kind of do that all in one step. You're actually multiplying by 3 and then dividing by 2. But again, my thought process is always, I see a fraction, we don't like fractions, get rid of it by multiplying by the denominator or the LCD.
I like the way you put it, because sometimes I'm like, I end up with too many numbers all over the place. And
Yeah. Yeah. Well, that's why I'm doing notes like this, so you can easily go back and find the topic you're on. And they should be in order of the topics that you're doing them. So this one is the same thing we're just doing, but it's to get rid, you want to get the x by itself, so you want to divide by negative 5. It's just a negative, so positive divided by negative would be negative, so it's negative 4. On this one, again, as soon as I see the fraction, I'm like, get rid of it. So you can do the LCD. The LCD of 3 and 5 would be 15. So I multiply both sides by 15. And what you do here is 15 divided by 3 is 5. Actually, let me use a different color there. 15 divided by 3 is 5, and then 5 times negative 2 is negative 10. And here, 15 divided by 5 is 3. 3 times 4 is 12. Now you have a problem without fractions, and most of y'all can solve this one just fine. So divide by negative 10. And x is equal to negative 12 over 10. Again, the fraction, I think I said this on Monday, but the fraction is the whole thing is positive or the whole thing is negative. So I have a positive divided by a negative, so the whole thing is negative. And then you can reduce this down. You could divide both these by 2. And get negative 6/5. On this one, 3 over 4y equals negative 9 over 2. So my LCD on this one is going to be 4. So if I multiply both sides by 4, 4 on top and 4 on the bottom cancel out. And 4 divided by 2 would be 2. So 2 times negative 9 would be negative 18.
And if it's improper, is there any way in the test that it's going to turn into a mixed number?
No, we never really change it to mixed numbers. We always just leave it as improper. Like, that's when you go further in math, like, you can't really do anything with mixed numbers. You always got to change it back to improper, so we just leave it as improper. I didn't say this, but divide by 3 to get your final answer. Negative divided by positive would be negative. And on the test, like, it probably will give you partial credit if you, like, don't reduce or something like that, but then we can always review it, and I can go in and give you partial credit too. All right, here's a two-step equation. We've actually already kind of jumped ahead and did these, but that's fine. The goal on these is still to get x by itself. So you start furthest away from x, and I want to subtract 5 from both sides. Now I have the term with the x by itself. And then I can divide both sides by 2, and x equals 3. This one, this is a good one to do. Okay, so on this one, we have a negative x plus 4. So again, get rid of the 4 first. Get rid of the term without the x first. This is negative x equals 6. So this is like having a negative 1 out in front. So I need to divide both sides by negative 1. And my answer is actually negative 6. So when you have a negative x, it's like having a negative 1 in front. So divide both sides by negative 1. This one shouldn't be too much different than what we've been doing, but you got the 5y, so try to get the 5y by itself first. So I add 2 to both sides. And then to get y completely by itself, I divide by 5. And again, I know we haven't said this since the first problem, but you can always take that and plug it back in to check to make sure you got the right answer. A little bit harder ones when you have negatives in it, but still works the same way. I'm trying to get this term by itself first, so I need to get rid of the 4. So I subtract negative 4 from both sides, and I get negative 8 minus 4 is negative 12. And then divide both sides by negative 3. So x is positive 4. Negative divided by negative makes it positive. All right, getting into some distributive. So what you want to do is you always want to simplify everything on the left side, simplify everything on the right side till you can't do any more, then start moving stuff across the equal sign. So on this one, this is a distributive property. So I'm going to take this 4 times everything inside here. I do 4y minus 8 equals 8. Now this looks just like the problems we were just doing. I'm going to get rid of this negative 8 first by adding 8 to both sides. So I get 4y equals 16. And then you could divide by 4, so y is equal to 4. I'm going to show you one other way to do this just because it makes me mad that no one ever shows this, because it does come in handy later on. When we had problems earlier, don't write this part down, but when we had problems earlier, we had what? 4 times something equals 8, right? So on this one, we divide by 4, right? Because this is 4 times something equals 8. Well, this problem right here is the same exact thing. We have 4 times something equals 8, even though that something looks bigger. This is 4 times something. So one thing you can do on this is you could actually divide by 4 to start. And these 4 cancel out, and I have y minus 2 equals 2, and then add 2 to both sides. There is a scenario where that comes in and makes it easier later on in the semester. But again, you don't have to do that. It just, there's a different option there. And like I said, nobody ever really shows you that. That is the same thing. This is 4 times something, so you can just divide to start. All right, so just like previously, if there is something you can do on the left side or the right side, you do that first before you start moving stuff. So on this one, I can combine like terms first. 3x plus 2x is 5x, and then divide both sides by 5. So x equals 2. So it looks like some more of that. You always want to simplify as much as you can on each side before you start moving stuff. So 7y minus 3y becomes 4y. And that's all I can simplify because this has a y and this doesn't. So now I'm stuck. I can't do anything else. Now I start moving stuff across the equal sign trying to get y by itself. I subtract 4y from both sides and divide by 4. All right, on this one, I can't do anything on the left side because this has a y and this one doesn't. I can't do anything on the right side because this one has a y and this one doesn't. You always check that. Can you simplify on the right? Can you simplify on the left? So I need to start moving stuff across the equal sign now. And the first thing you always want to do is get your y's together. So I subtract 2y from both sides. And I get 3y. Just bring the 3 down. These cancel out, and I got 6. So now it looks like just like the problems we were doing, my y's are together. So now you have y's in one spot and get everything away from the y. So I add 3. 3y equals 9. And divide by 3. Y equals 3. All right, so on this one, again, try to simplify. There's nothing I can do on the right-hand side because there's just one number. But the left-hand side, I can do a bunch of stuff. I could distribute the 2. Plus 2 times x is 2x. 2 times 3 is 6. I don't want to on this one. This is why I don't like to do this. But this one, you don't want to divide by 2 to start because the 2 is only being multiplied by this. You still have this thing over here hanging out. So the scenario where you do this, where you divide by, only really works when there's only this thing right there, if that makes sense. This one, you have this 4x here bugging you, so you don't want to do the division thing. So I distribute, and now combine like terms, right? 2 2x and 4x is 6x. And now I've simplified as much as I can on the left-hand side, so we're going to start moving stuff. So I subtract 6 and divide by 6.
Is there going to be any word problems on the test?
We'll go over exactly what's on the test when it gets closer. I try not to put too many, but there might be one or two. All right, so on this one, again, we need to simplify on the left-hand side, so I get 4y minus 8 when I distribute. Now I have y's on both sides, so I want to get my y's together. So I'm going to subtract 2y from both sides. And then start working on getting the y by itself. So I add 8 to both sides. And then I'm going to divide by 2 to get y completely by itself. Y equals 7. All right, some fraction ones. All right, so a lot of you may see this and say 2/3 x plus 1/3 is just going to be 1. 2/3 plus 1/3 is 1 because 3/3. But I'm still going to do it the LCD way because I just want to get rid of fractions. I don't want to look at them. So my LCD is 3. They're both 3. So if I multiply everything in here by 3, it'll make the fractions go away. 3 on top, 3 on bottom cancel out, so I get 2x. 3 on top, 3 on bottom cancel out, so I get 1x. 3 times 5 is 15. Now I can combine like terms. 2x plus 1x would be 3x. And divide by 3. X is equal to 5. All right, this one, 3/4 y minus 1/2 y equals 2. How many is left? Sorry. Oh my goodness, 24, okay. All right. So on this one, again, you can add or subtract. You'd have to change the denominator and make a common denominator. I'm just going to multiply everything by 4. This 4 is my LCD, so I'm going to multiply this by 4, this by 4, this by 4. 4 on top, 4 on bottom cancel out. Here, 4 divided by 2 is 2. Be careful with your negative right here. This is negative 1 times 2, so this is negative 2y, and it equals 8. And then 3y minus 2y would be y. So y is equal to 8. 3 minus 2 would be 1. All right, I think this one is some like special case scenarios. So we have an x on the left and an x on the right, so get those together. When I subtract 2x, 2 minus 2 cancel out, and 2 minus 2 cancel out, so I get 3 is equal to 5. My x's kind of go away. Well, 3 does not equal 5. If this ever happens, this is no solution because 3 does not equal 5. So that problem does not have an answer. There is no answer for that.
It's like going on forever.
No, that would be this one coming up, I think.
So would you just put like?
The answer is actually no solution. Like, there would be a spot where you can put no solution.
Okay.
Yeah. On this one, we want to distribute the 4, so I get 4y minus 8. 4 times y is 4y. 4 times negative 2 is negative 8. So when I go to combine my y's, I subtract 4y from both sides. Well, again, they both cancel out. So I get negative 8 equals negative 8. Negative 8 does equal negative 8. So what they say here is I could plug in any number that I want and it would work. They could say it's all real numbers. All real numbers because negative 8 does equal negative 8. That means I could plug in any number I want. She said it goes on forever, like there's an infinite amount of solutions. I could plug in 2 million and it would work on both sides, right? I'd get the same number on both sides. All right, this one, x plus 3 divided by 2 equals 5. This is another scenario where these are the problems I'm kind of thinking about. I just want to get rid of it. It's a big, scary looking fraction, so let's just get rid of it. We can do that by multiplying by the LCD. There is no really LCD here. There's just one denominator. But if I just multiply both sides by 2, 2 on top and the 2 on the bottom cancel out. 5 times 2 is 10. And now I have a much easier problem to solve, right? I subtract 3 from both sides, and x is equal to 7. On this one, same idea. I just want to multiply by the denominator. So if I multiply both sides by 3, 3 on top and the 3 on bottom cancel out. So I have 2y minus 1. 4 times 3 is 12. And then to get y by itself, I'm going to add 1 to both sides. So I get 2y equals 13. Divide by 2, and y is 13 over 2. That's fine. Just leave it as 13 over 2. All right, the last few topics, we're going to use all those same principles, but we are going to work on just solving for a variable. Okay, so there's going to be multiple variables, and we're just going to find one and solve for it. So if I'm trying to solve for x, that means I'm trying to get x by itself, so use those same steps. Try to get everything away from the x. I'm going to subtract y from both sides, so I get x equals 5 minus y. And that's it. That's my answer. I have x by itself, so I have solved for x. On the next one, we are trying to solve for w. Oh, it's got a negative in there, so that's not fun, but we'll talk about that. Solve for w. So I'm going to get the w by itself, so I'm going to subtract the z from both sides. So I have negative w equals 3 minus z. But I still need to get the w by itself because of that negative. So this is like a negative 1. So what I'm going to do is divide everything by negative 1. So negative 1 cancel out. 3 divided by negative 1 becomes negative 3. Negative z divided by negative 1 becomes positive z. When you multiply or divide by negative 1, it actually just changes the sign. This went from positive 3 to negative 3. This went from negative z to positive z. Okay, So to get rid of the negative w, we change the signs of these by, you can just divide everything by -1. But you got to make sure you divide everything by -1. X plus 2y minus z equals 4. Solve for x. So if I'm trying to get x by itself, I got that 2y and that z bugging it. Let's do 2 steps at once here, see if you can handle it. I need to get rid of the 2y and the z, right? So I'm going to subtract 2y and I'm going to add z. Subtract 2y and add z. So I get x equals 4 minus 2y plus z. And I do not put anything together because the 4 doesn't have anything. The 2 has a y, or the negative 2 has a y, and the z. So they can't combine those at all. So it's just, I'm moving everything away from the x. This one's basically the same thing, but we'll do it real quick. What are we solving for? Solving for a. Yeah, this one's not going to work any different, really. So I'm trying to get a by itself. So I need to get everything without an a away from it. So I add 3b and subtract c. Add 3b, subtract c from both sides. So I have a equals 7 plus 3b minus c. Solving for a, so I'm getting everything that doesn't have an a on it to the other side. And once a by itself, you have solved for a.
So you don't have to do it with both sides for the addition, for the 3 and the c?
Yeah, I did it for both sides. Like, see, I wrote it here. So it's minus 3, so I did plus 3b and c. Yeah, and then this goes to the other side over here. All right, this one says 3x equals y, and we are solving for x. So to get x by itself, I'm going to divide both sides by 3. Those cancel out, and I get x equals y divided by 3. I guess this one's the same thing. I didn't pay attention to that. Solve for w. So to get z, oh no, we're solving for z. So I already solved for w. Solve for z, we divide both sides by 2. So I get z equals w divided by 2. The last topic here, same stuff we've been doing. We were trying to solve for x on this one. Looks like it got a little bit harder.
Again, for that, the other one, if you were to write like w and then the actual division sign, would that still be correct? Or would you put it like
I don't think they'll let you type the division sign in there. The only other way you could write this is you could write it as 1/2 w, like that.
Okay.
But I don't think they let you put the division sign. They just let you do the fraction. All right, so just like we've been doing, like get rid of the fraction. So my LCD here is 2, so I'm going to multiply both sides by 2. So these cancel out, and I get x plus y equals 3. I'm sorry, I forgot to multiply that by 2. That's the most common thing to do. 3 times 2. You got to multiply everything in it by 2. That's the most common thing to do when you make a mistake, just like I just did. You got to multiply everything by 2, so don't forget to multiply that 3 times 2. So now we have a very easy equation. We're trying to solve for x. So I'm going to subtract y from both sides. So I get x equals 6 minus y. And then the last one, z minus w over 3 equals 5. Solve for z. Again, let's get rid of the fraction by multiplying by 3. 3 on top, 3 on bottom cancel out, so I get z minus w equals 15. And then to get z completely by itself, I add w to both sides. So I get z equals 15 plus w.